Lastly, I'm going to discuss diffraction. So diffraction is the idea of when a wave passes through a boundary that it actually sort of drags along the edges and is deflected and curves or bends around those barriers. So we've already sort of seen this in the Young's double slit experiment. So we had two slits and we saw these interference patterns that arose because as the light traveled through a boundary, that light then was bent, and we were able to see, areas where the light would either constructively interfere or destructively interfere. Now, a common tool for studying light is called a diffraction grating. And a diffraction grating is a piece of glass or film that has slits scratched into it. And those slits are categorized by how many slits there is per unit distance. So when you get a diffraction grating, it would say, like you can see here, this one says 300 lines per millimeter, okay? Now the equation for studying diffraction patterns through a diffraction grating is the same as the equation that we've seen already before, where in that d sine of theta equals m times the wavelength. And m is the where you see the interference pattern, okay, or the bright fringes, either the 1, 2, 3. In the case of a diffraction grating, we're typically using a monochromatic light source. So the light source is one wavelength, and typically it's a laser. So we see sort of bright spots appear as the light bends and escapes through the slit, instead of seeing those sort of bands. And I'll demonstrate this in class, and we're actually going to do a lab with this. So in this case, again, let's just redefine what these variables mean. You've got d sine of theta equals m times the wavelength. So m is the order number, whether it's in the center is the 0th order, and then the first dot would be the first order, and then the second order and the third order, okay? The wavelength is the wavelength of the light, and d is actually the distance between the slits. Now, for a diffraction grating, you're given the number of slits that you have, or number of lines that you have per millimeter, so or centimeter or inch sometimes. So really what we need to do to actually calculate d is take the inverse of that to determine the distance between the slits, okay? So for example, here we've got 300 lines per millimeter, and really what we need to do is have this in meters, not in millimeters. So you need to multiply this number by 1,000 to get it in meters. So you've got actually 300,000 lines per millimeter. Then if we take the inverse of that, so you just take 1 over whatever that number is, that will tell you the d, the distance between the slits. So 0.0033 millimeters, or it would be 0.0033 times 10 to the negative third meters. Okay, now the equation is still the same. We're still dealing with the sine of the angle. So the angle is easily calculated by looking at the distance between the diffraction grating and the screen at where the fringes appear, and then also measuring the distance from the center point of the laser or the monochromatic light source to the distance away that this point is. So you would have a distance here and a distance here, giving you a right triangle that would then allow you to calculate the angle. And again, we'll do this calculation in class as well as doing a lab and a demonstration.